All right. Hello, everybody. We're back again. This is Adam with National Comfort Institute, and this is the High Performance HVAC podcast. And we're coming up to the tail end of Summit this year in Texas. And I am talking to a friend of mine and mentor right now, somebody that I've looked up to for a long time and idolized. Um,
I'm trying to figure how you look up to me, considering you're about 6 or 8 inches taller than I am. So I kind of get a kick out of that.
yeah, no, but yeah, Ed Janowiak. And I said that correctly,
You
right?
did. You're one
Yeah,
of the few people that don't need to be corrected, but it's not as if people very often pronounce it correctly. So
very good.
it's just like my height. It's part of my shtick. So it works
Hmm.
out pretty good.
Yep. So yeah, Ed goes around and makes people kneel down, basically. Not really kneel down, but you.
Yeah.
So you could take selfies with them and look just as tall or taller than them, right?
I've uh, at the symposium last year down in Florida, I had a couple of the guys that are in the 6'3", 6'4", 6'5" range that are literally on their knees, and I'm gonna say they at least came up to my earlobes like that.
Hmm.
So it's a shtick, but at the same time, I'm gonna say I'm at 150 pictures right now.
Mm-hmm.
So eventually, I'm going to give all the photos to my kid, and she's going to make some kind of a collage or some kind of a video,
Mm-hmm.
and I'm going to do something with it. I don't know what I'm going
Very
to do,
cool.
but
You have a
something.
lot of cool people that you've taken pictures with too.
Oh, I do. I'm sort of lucky. I've been around in these groups for a long time, so there's a lot of very notable people that maybe it's a little weird that I'm going up and asking to get a picture, but at the same time, they'll make the comments about, oh, I see your videos and I see you on social media. And I'm like, well, you better stay off of some of them sites if you're seeing me. So it's kind of funny, but I don't know. It's like the Michael Scott stuff with, I've always wanted to be part of an inside joke, and now I am. And it's good stuff.
Yeah, but you're HVAC famous. I mean,
Uh, this goes back pretty far. When I got a daughter, Andrea, who's 26 years old, and from the time she was 10 years old, 11 years old, I used to tell her I was famous, and she would roll her eyes and she'd make like a huff noise and all that kind of stuff. And I really wasn't, but I guess you could say I was starting to be. My job was going around and training people. Most of it was right local in the Northeast, Mid Atlantic, whatever you want to call it. I'm from New Jersey, and it was sort of local, but it started branching out. And I could say, well, I went as far as Florida, or I'd been as far as California, and I was going to Las Vegas, and I was going to these places, and it was eventually becoming true that I was nationally known. And she would continue to roll her eyes until we're to where we are now, and I can go places. And it doesn't happen that frequently, but it does happen where I'll be someplace. I'll be in an airport. We go to Disney a lot, and I've been these places, and somebody go, "Hey, Ed," and they, are genuine, and my wife or my daughter will, was that for real? Did you pay them to do that? I'm like, no. Do you know who it was? I'm like, could have went to high school with him. It could know him from the golf course, or most likely when they say, "Hey, Ed," because that's the name of one of the video series I have, they recognize me from work,
mhm.
and it's almost as much fun as when a stranger compliments me on my beard in front of my wife, because she's not a big fan,
Uh-huh.
and uh, it's fun to razz her about it. So
Mm.
it's interesting.
Well, you also, I'm sure this helps out the situation. I don't know if you still do this or not, but I remember when I took a class with you, the 3-day design class, um, you made a point to make what was it, a Snapchat?
Oh yeah.
So you still do that?
Oh, absolutely. I felt a little weird today about doing it because it was a big enough crowd that uh, I've spoken in front of more people. I'm going to say there was 250 people
Hmm.
ish in the crowd today, and I've had bigger crowds than that where I've turned around and I've done it. If I was doing something where I was invited that was a little more, this place isn't stuffy, and I don't want to make that assertion, but I would have felt a little out of place doing it here. If I was here for my own employer, I don't care. I would have done it in front of them.
Hmm.
And a lot of the classes I do, I get everybody to say, "Hey, Andrea, your dad did a great class," or something like that. So
Hmm.
yeah, I still do that. If I'm doing one of my normal trainings where I have between 5 and 45 in a classroom, we still do it then. Uh, if I come up with something that I think is really funny or something happens, next week I'm in Salt Lake, and I had no idea that there was a train 30 feet behind the supply house that the training room we're using goes by. And while I'm talking about, I don't know, shading from trees, I grabbed my phone and took a Snapchat of the train going by because I had never done a class where I had to talk louder to overcome the sound of the train going by. So I'm a little bit old, or maybe I'm a lot old, and people are kind of surprised when they hear that I'm a Snapchat guy. And it's Skinny Ed, all one word, if you're interested. And my stories are pretty good.
Nice. So you were talking about before your daughter and after your daughter, right? We were talking just before this, and you brought up measuring BTUs and
Yeah.
performance from years ago. So,
So many years ago, uh, and again, Andrew's 26, so I do the before Andrea or BA or AA after Andrea, so I can date where I was and what time I was doing stuff. I started teaching right around the same time she was born, and it was well more than 26 years ago. And I'm going to say it was a solid 5 or 6, maybe 7 years before she was born. I was involved in a utility program through my employer. My history, I spent 15 years in a service truck before I started speaking in front of people where I got paid for it. And the utility was trying to keep the gas company out of all electric neighborhoods. And the way they went about it was to pay us, and it was the company I worked for. We had another company we work with, Optimal Energy, and they were the blower door people. They were the air sealing crew. They were the duct sealing crew, and we were the management side of it. But I was also the heat pump guy, and I trained with Proctor Engineering from California. A fellow by the name of Tom Downey taught me how to measure performance on a heat pump. And the way he showed me how to do it is the way I've shown other people how to do it, where you watch them check a system and you stand there with your arms folded. You let them flounder around because if you don't know what you're doing, there's not a whole lot you can do with a heat pump to check its performance, beyond sticking your hand over the vent. Yeah, it's coming out hot, and you can't grab the big pipe because it's going to burn your hand, that kind of a thing. And after watching me for a period of time, he's like, "Well, it looks like you know what to touch and what not to touch. So let's actually do it." And doing it is really nothing more. And I love saying that it's really nothing more because it's like tying your shoes. Once you know how to do it, it's fairly simple. But measuring the performance on a piece of equipment is even easier today because of the tools that are available. But I still feel confident saying I could walk up to a heat pump in the wintertime and tell you what the coefficient of performance is, or I'm going to say COP moving forward. But I can tell you the COP of that piece of equipment with a voltmeter, a split core or amp probe, a stopwatch, and a thermometer that will allow me to measure two sensible temperatures. And if I know the airflow, which if I'm working on an air source heat pump that has electric resistance heat, I'm able to solve for that formula that wants to quantify the heat. So I can get BTUs, and I can get pretty close to what the real BTUs are because the electric resistance heater are 100% efficient. So I do amps times volts divided by delta T times 3.16, and that solves for CFM right there. It's a little bit of a fancy math. It gets rid of the 1.08 and doing some other stuff. And again, somebody showed me that a long time ago. And as I'm saying this out loud, it's every bit of 30 years ago I learned that. And I did it so many times. And I don't know if I can say I did it 1,000 times, but it's pretty close. So here I am 30 years later, and I'm like Rain Man regurgitating this stuff because I can do it off the top of my head.
so can you say that formula again? I'm curious because I've always used the 1.08.
So you do amps times volts um, divided by your delta T times 3.16. And I think the 3.16 is the 3.412 divided by the 1.08, or flip those two numbers, and that's how you solve for it.
Ah,
So if I'm taking a multiple choice test and on the multiple choice test, the answer is determined with the formula that they provide for you. It comes out like 1 CFM difference at 1200 CFM versus I'm going to come out at 1199 or something. So it's, for all intent purposes, it's a close enough test. So that was my introduction to measuring airflow. Then the next thing you do if it's winter time, you're going to run the heat pump for 15 minutes. I stretch it out to 20 because I didn't want to get done too early, and I would let it run for 20 minutes with just the heat pump, no electric resistance heat. And you would take that airflow that you got with the temperaturized method, CFM times delta T times 1.08, and that gave you your sensible BTUs, where you could take that CFM times delta T times 0.317, and that solves for watts. And if you want to turn that into BTUs, you could take that watts answer times 3.412. But I wasn't interested in that because I was provided with a bunch of charts that gave me the coefficient of performance, or COP, at the I don't know, anywhere from 60 degrees down to 0 on a
So you
chart.
need to, if you're trying to figure out solve for COP, you're skipping a step.
I'm not there yet.
Okay, sorry.
I haven't done my watts input yet. And the cheat is really not. I can't think of a better. Well, I could do it better today because I have a split core meter that can do power factor, and I can get everything that I needed. Back then, I didn't have it, so I literally would shut all the breakers off in the house except for the fan coil in the outdoor unit, and I'd stand next to the meter. I'd light up a cigarette. I had my Casio G-Shock. This is all before cell phones, to put things in perspective, because I'd be using my cell phone as a stopwatch now. But I had my Casio G-Shock watch, and you would look at the meter, and there's a mark on it, on that dial that spins. And when it comes around, and there's a mark on the front of the meter, you start your stopwatch, and you would time it for, I think it was 2 minutes. And after you counted, I don't know, 14 spins, the next time it came around, you'd hit your stopwatch, and you'd be at 122 seconds. Right on the meter, there was a KH number. So you would take uh, the KH times the number of revolutions times 3,600. That was the math in the meter. And you would divide it by the number of seconds, and that gave you input watts. So if I had input watts, my temperaturized part of the process gave me my heat pump's output watts, and output divided by input is coefficient of performance. And basically, what I learned later was we were looking for approximately 90% of that machine's capacity, because you're not going to be that close with your tests. But if we were at 90% or better for our test, we said, all right, it's working right. And a big exposure to me on this stuff was I had a lot of days where it was 2:30 in the afternoon and I was done, because part of my job was to make people feel better about their heat pumps. And it's funny because I've dealt with heat pumps for a very long time, and people live in houses with heat pumps don't understand them. And they would make the normal comments. They blow out cold air. No, they blow out warm air. It's not hot air like the air that you're used to coming out of a fuel burning furnace. And I would see a poor, poorly selected registers. And I would see these plastic things with magnets that would blow the air into the room. And people would do all the stuff that we tell them not to do. Because if you do a proper distribution system, you don't blow air on people, you don't blow it into the occupied zone. And basically explain to them you only need air that's a couple degrees warmer than the indoor temperature, if there's enough of it, to maintain temperature in the space. So some consumers really weren't all that interested in what I was doing. They just wanted lower bills and a more comfortable house. And my whole purpose of being there was to make people happier with their heat pumps, so they wouldn't sign a contract with a company, because the gas company's goal was 40% of the occupants in this 250 house subdivision, get them to sign a contract. They would run main, and then eventually the gas company would take over that winter load that the electric company was trying to avoid losing. So that was the whole purpose of this program. So I would test the machine in the wintertime. I could do that. And then I could also do it in the summertime. And summertime is when it gets a little more, I can't believe I'm going to use this word, but it was more sexy.
Hmm.
The airflow test was the same, but now I have the ability to take a psychrometric chart and I could essentially do three math problems plus my watts input. We already did how you clock the meter. So the three inputs I would do, I would use the psychrometric chart to take a couple of dry bulb temperatures and plot them, a couple of wet bulb temperatures and plot them. And then the psychrometric chart that I used also had an enthalpy chart on it. So I would do my sensible calculation, airflow times delta T times 1.08 gives you sensible BTUs. You would take the psychrometric chart and plot your wet bulb temperatures and where those two intersections live on the psych chart horizontally to the right would take you through the grains per pound bar. And then I would get my difference in grains. So CFM times delta W, which is change in grains, times 0.68 solves for latent BTUs. Add them together, you have total. I would also take the wet bulb temperatures, use the enthalpy chart, and enthalpy is the total heat content of air, and I would take those results and compare them to my total capacity that was split between sensible and latent, and our number was 5%. If those totals came out within 5% of each other, I was done. Or I could rely on that measurement and I could compare it to my watts input calculation that I would do, and I would get an operating EER. Again, to put this stuff into time frame, this was pre ARI guide, which was pre AHRI certificate number, website, and all that. We had a thing called the Carrier Blue Book, which one half of the book, if you opened it from, I'll call it the front, did your EER and your BTU capacity for a heat pump or an air conditioner. Then, if you flip the book over, it was the front again, and that was for a gas furnace, and that's where these capacities were originated.
For the like a matchup.
And it wasn't a matchup; it was outdoor unit only.
Hmm.
So it was not nearly as a sophisticated list as what we would see with the AHRI guide, but that's what we had. We didn't have we had the manufacturer still would supply, let me rephrase that, at least some of or most of the manufacturers did provide expanded performance data in the same or similar format that we see it today. It just wasn't as extensive then as it is now.
That's interesting.
But the whole reason the utility was really doing it was because they were trying to keep the gas company out of the market so that they could maintain that winter load. Because electric companies, it's well, it's like a lot of things. It's just like being an HVAC contractor. Your peak demand is when it's real hot out, and that's the same way the electric company works. And they have to build infrastructure. I say that right? Infrastructure.
Yeah. The
Came out
second
the
one.
yeah.
Yeah.
They have to build a supply that meets the peak, and they're going to do everything they can to try and avoid that peak. And if you can make existing houses, more efficient, well, that's sort of what we were doing because I was testing the heat pump, but we had another crew that was going in doing a blower door test, sealing ductwork, doing all that kind of stuff to reduce the the demand on the house. I was in a class just before where they were talking about permanent reduction, and it's neat to hear some of these terms that people are talking about. And I'm like, well, crap, I was doing that 30 years ago. It was how you do stuff. So it's nothing that's new. Yeah, Chris
Chris
was in
Hughes
there.
is walking up. He could sit down with us, huh? Hang out.
Yeah. So it's that whole permanent reduction thing. I just started hearing that, but that was my introduction to a lot of this stuff. I talk about old stuff. We were, I don't know if I was just talking to somebody or we were in a, oh, actually might have been the big session that we did today. And somebody asked about measuring the pressure difference across the bedroom door. And I used to use my face to do it instead of a DG8
Hmm.
because the DG8 didn't exist. I might have had a DG2 then, which was the predecessor to the DG3. But the duct blaster I have, that one originally came with analog gauges. And every time I say these things, man, I'm like, I'm freaking old. But to a certain extent, a lot of these things haven't changed, right? The problems that existed back then still exist now. There's just a lot more people that are well versed on it
Yeah.
that can address it. But there's also a whole lot of contractors out there that don't know how to do it right. And that's why we have so many problems with stuff, which it gets weird sometimes when I say things like, I'm glad a lot of these problems exist because I got a job because of it.
Yeah.
So it's pretty cool.
It's funny. Earlier we were talking about CM Fracco brought up John Tooley,
Hmm.
his paper Mad Air,
Yeah.
and he was saying how upset he was. He thought he was like revolutionary learning about this stuff, and then he looked at the date of the Mad Air paper, and he's like, "What the heck?" And I'm like, if anyone looks that up on the internet, that was like typed on a typewriter.
Yes.
That's old stuff. It's been around. The concepts have been around forever, right?
I have a laminated card that is the scale for the Mad Air thing that I want to say was somewhere around 1992, 93. Because again, I got involved with the weatherization aspect of things. I worked for a contractor that did demand side management, and that was helping utilities reduce the peak load on the demand side. So I worked on stuff where they used to put those radio controlled switches on equipment and shut stuff off,
Mm-hmm.
but we were trying to do it from a conservation standpoint. So that's how I got introduced into the whole blower door stuff. The company I worked for was pretty progressive with spending money on education. And I started going to the Affordable Comfort Conference in Philadelphia, sort of in its infancy. So I talk about different things to, if anybody's familiar with Affordable Comfort, which is the Building Performance Association conference now, I date myself to somebody that Chris works with, Gary. I was at their old place a couple years ago, and I was talking to Gary, and I said, I don't think for a second you would remember me for this, but I remember standing in a place in Pittsburgh and a place being somebody's basement, and Gary and John were in the basement with like 8 of us, and we wanted the answer. And the answer is, when does it become cost effective to start sealing ductwork? And they were like, I don't know.
Mm-hmm.
And when I asked Gary 30 years later, he's like, I don't know. There's no direct answer for that. There's rarely a time it's a bad thing to do from a cost effective standpoint, but it's certainly a bad thing to do if you're going to cause an issue. And anybody that's following this podcast, I'm going to assume has uh, at least a little bit of an idea when we start talking about combustion analysis and doing CAS testing and all that kind of stuff. So the weird thing that I got exposed to back then, and it's still a problem today, spending a lot of money on tests doesn't necessarily help anything. Spending money on any kind of measures to save energy, that can help.
Mm-hmm.
But when you do things because you think it's a good idea, you can create hazardous conditions. And it's, I think, mind boggling would be a correct way to explain it, to see how many contractors don't get this stuff and can create these issues. And
Yeah.
I'm lumping myself in there.
Oh
I
yeah.
can remember looking at uh, a, a furnace that's vented in combination with an atmospheric water heater, and that vent connector is all rusty. And the way I fixed it, replaced the pipe.
Yeah. Good to
And
go.
it was many years later I realized that there was something not burning right, and I should be addressing it. But if you don't know, you don't know. And hopefully you don't kill somebody in the meantime.
Yeah, I want to go back for a second and talk about you don't is it beneficial to just start testing everything, and that goes back to, I don't know who I've heard it say it first, but it's like, you don't need to make every house a science project,
No.
right? But there's certain situations where um, you could charge 1,000, 2,000, 3,000 to go through and make it a science project. Or if you start seeing red flags throughout the house, you'd be like, why don't we just start taking that money and fixing some of the things that are like low hanging fruit,
Oh yeah,
like sealing the ductwork or air balancing, or reducing the pressure drop across your filter. Let's do some of these
sure.
easy items and take that money that you would have spent testing, and we'll just fix the things that I know are broken right now. Right.
Absolutely. And you can make that testing extremely extensive, or you can do the fast and dirty stuff. The simple idea of taking a quality manometer and taking a couple of quick zonal pressure tests going into a house, air conditioning season. Uh, I'm still a big advocate of estimating the airflow in the quickest way possible I can, and then measuring a difference in enthalpy. And there'll be times I won't even do the airflow thing. I'll just measure my supply and return enthalpies. And if I end up with a number greater than 7, I suspect that there's an airflow issue. If I end up with a number that's greater than 6, excuse me, less than 6, I have a starved evaporator. So it gets into the non invasive testing. And this these kinds of tests come with some background, with some knowledge. It's not 100%, but it starts you on the right path. So if I'm talking to somebody who likes measuring the delta T across the piece of equipment, after I get done picking them up off the ground because I punch them in the throat and tell them to knock it off, I introduce them to the wet bulb temperatures and this enthalpy process. Well, Joe just walked away from Measure Quick. You don't have to understand this stuff. You have to trust the technology, and you can do a non-invasive test with Measure Quick that just does exactly what I said, or maybe not exactly, but it'll give you the same results or point you in the same direction. And you're letting an app that has thousands of years of experience combined built into it sum up an answer for you that's very similar. So that's I like talking about this stuff from my background of doing it pen and paper or analog or however you want to put it, and then comparing it to what's available today to try and get people to spend the same amount of time to test the system quickly or more extensively, but use technology to give them good answers. I recently was talking to a fellow by the name of Brian Feeney, and Brian made the comment about people really don't need to understand this. They just have to trust the technology. And it borderline made my eye twitch because I want everybody to understand it. But as he's saying this, I'm like, you know what? Shit, he's right. Simply for the fact that I'm not going to get everybody to understand what I'm explaining, at least not in a period of time that first summer they're going to be ready to do this.
Mm-hmm.
So let them use the technology. Take that guy or gal who's going to go out there and change filters and make sure the drain is draining and that kind of stuff, and give them the ability to test the system. Maybe not 100% accurate, but that's close. That's better than a sensible delta T, because that's a test that I think if somebody actually understand how an air conditioner works, they realize what a I don't want to say worthless, but it's not a test that really tells us anything unless we know the volume of air moving across the coil. And it takes a little bit more time to figure that stuff out.
Yeah, and there's if you're, I'm sure like anything else, you see people on Facebook talking about Delta T, and you get a range of different responses. Somebody's like, "Well, what's a good Delta T to have?" And it's like, well, it's a pretty big range. Like, so, like if you're looking at that to try to figure out if the system's operating correctly, you need a lot more information to figure out what's going on, because like it depends on the day.
It's absolutely true. This past summer that we've had, at least in the markets that I'm familiar with, and the markets that I'm the most familiar with, again, Northeast, Mid Atlantic, and my kid lives a half hour north of Cincinnati. So I know what's going on in her neighborhood. I convinced her and my son in law or future son in law, whatever, uh, that they bought a couple of those Govee things. And if you're not familiar with the Govee digital hygrometer, $10 and access to Bluetooth, and they'll tell you everything you want to know. They're adjustable. You wait for Tech Tuesday or Black Friday, and you get 3 for $20 instead
Hmm.
of $10 a piece. I have them all over my house, and I don't know. I'm not too tied up in this stuff, but at the same time, I can be doing a virtual class from my basement, and I can look at my phone. I can get my uh, conditions from my thermostat for the return. I have one of those Govies deployed in the closest terminal in a primary bathroom that's on the first floor, so I can get my delta uh, for my enthalpy. And I know I'm 538 on CFM total for that downstairs system. So I can tell you exactly that on low speed or first stage of my 2-stage geothermal heat pump, I'm making like 18.5 in BTUs. And I like to explain this stuff in such a casual way to people. You can just see their head cocking to the side, like, what the hell are you talking about?
Mm.
But it's like anything else. I use the analogy about tying your shoes. Once you understand this stuff, it's really simple. But with technology today, you don't have to understand it like that. Just put the numbers into an app and then you can make the decision yourself. Is that good or not?
It kind of does it for you. That's kind of the along the lines of what Comfort Max is. What what we worked with Measure Quick, Jim Bergman, and that to create, and it does make it really easy. You don't have to look at each individual temperature. You could just hit capture, and it's
Yes.
all like one shot, instant. You know what I mean? You do really kind of have to understand the airflow and the delivered airflow. And if you
Hmm.
walk up to a random house, it's not as easy as you understand the airflow of your house.
Sure.
So if you're walking into a stranger's house, you don't really understand the airflow without testing it. So you do have to take
And you
measurements.
test it. And in this day and age, the idea of using the True Flow grid, uh, I remember Tom Downey from Proctor talking about this new gadget that was being worked on that had a bunch of holes in it. Any idea what I'm talking about, Chris?
Uh, version 2 of the blower door.
No, it was actually the legacy True Flow.
Yeah, no, I know what
Yeah,
you're
yeah.
getting at.
But that was something that was coming down the road. Back then, I never had access to it. The majority, and I'm going to say 95% of the airflow testing I did back then on the heat pumps was temperaturized. And I've had conversations with Steve about how I learned how to. I had a duct system. 2/3 of the ducts went west, and a third went east. And I used to put the number in the temperaturized that was 2/3 of the duct, and then I would write that down twice and once going in the other direction. And when I added it together, then my external static pressure started to match the blower table. But if I did one and one, it didn't. And Steve kind of smiled and went, "Well, that's a weighted average." That was when I learned what a weighted average was, but I had done
Hmm.
it 100 times because I messed around with stuff. I started talking about that a little bit earlier. I used to do stuff because I didn't want to call the shop and say I'm done because they would find something for me to do. So I would find a way not to get caught sleeping in a crawl space or an attic. And I used to get checked up on enough that I was concerned about that. But I would take the filter out of a piece of equipment that I already tested and it was fine, and I would put the filter in a half of the filter I'd put in a garbage bag and stick it back in the machine, and I do my airflow test, start to finish, doing a temperaturized airflow test on one of those machines. You would let it run for 5 minutes, and by the time you went to the meter and did all, it was a 15-minute test. So that got me closer to the magic like 3:15 time that I could call the shop, and they'd say, "Yeah, just go home." And I didn't go home; I'd go play golf. But there was a chance that when I would finally call the shop, I was in the parking lot of the golf course, and I was just like wincing that they're not going to say, "Oh, we got a call for you." But I would do the same thing with the heat pump running as in heating mode or in cooling mode, and I've had some really good discussions when people will say, "Oh, an air conditioner won't run below 300 CFM per ton," and I'm like, I've seen like 50 of them running at 235 and 240. And like, well, how do you know? Well, you put half the filter in a garbage bag and kill time so you don't get caught goofing off. And I learned so much because I was trying to avoid doing something else. And the weird part with all this stuff, all this measured performance testing I did, I used to think it was stupid. because I could never foresee a homeowner wanting to give me money or my employer money to know how many BTUs that machine's making. And I don't even know if really I mean, it is kind of a thing, but not really. But at that time, I never knew I was going to be teaching classes. So the simple idea of I understood superheat and subcooling, but not only understanding the charge, I understood the airflow aspect of it. I understood the static pressure part of it. I understood how the system worked, and I could whip out my psychrometric chart. And it's not because I'm that bright, but if you do something 500 times, it all becomes second nature. So, and I'm a perfect example of, if I can figure this stuff out, anybody can figure this stuff out, because well, I have very, very few things that I came up on my own, but it's third grade math and sixth grade science. That's the way I like to discuss it.
Yeah, I mean, when we're talking about BTUs, I do kind of agree. Like when you dive into psychrometrics a little bit, that gets a little scary, especially when you look at the chart for the first time. You're like, whoa, you
Well,
know.
I just recorded I think it's an 8-part series, 10 minutes on each topic, and dry bulb, what we use it for, wet bulb, what it is and what we use it for. And as I'm going through the things that you use on a psychrometric chart, I'm sort of giggling to myself, because I know how to use the wet and dry bulb stuff. I know how to use the enthalpy part of the scale, and the change in grains, and making sure people understand that RH really isn't a good metric to use, because it depends on the temperature of the air, or as I like to put it, the size of the container that holds that moisture. But there's stuff on a psychrometric chart that I don't know how to use it. Like there's a line that goes up on I think it's a 24.5-degree angle, and I just made that up, but it gives you the cubic volume of a pound of air. I don't know how to use that. I remember doing a class one time where I'm going through my whole measured performance and blah blah. I had a gentleman from North Jersey who was a college guy, and it was a local gas company class on system performance. And he brought his whole class. So he had like 18 students in this class. And I say, yeah, there's this other calculation, and you come out and where you hit it, and it's this line, and I don't know really what it is or how to do it. And he's like, oh, you want me to explain it? I'm like, yeah, I want to know what it is. And he explained that that's how much area or how many cubic feet a pound of air takes up. And I'm like, that's it? And he's like, well, yeah. I'm like, well, how do you use it? And he goes, I don't know. So I always thought that was pretty cool. But there's some other stuff on there that I don't use, and I'll talk about it, but I don't know how to use it. So as soon as I go over this is how you get there, but I don't know what to do with it. So uh, figuring out your specific density or something like that, that's the whole altitude correction and that kind of crap. But there's stuff that definitely gets used and stuff that doesn't. But after you do a bunch of these tests, not so much in the wintertime, but in the summertime, you start to realize how things line up. And you also start to see trends. And this starts to come back full circle with taking a dry bulb uh, Delta T, and how that can, I guess, somewhat be helpful, but at the same time, it can be crazy misleading, because you can have a 12-degree Delta T on a hot summer day, and that's correct. It could be a lower number than what we might expect, because the airflow is much higher than you realized. It could be because it's humid AF in that house. And before you think something else, AF stands for airflow. Just,
Yeah.
was it? You don't get it twisted. That's. I actually start my classes off. I have a QR code. I have a whole bunch of the different acronyms that I use. I use WTF all the time, and I bring that up right before lunch because it stands for "Where's the food?" That kind of stuff. And it is fun. In fact, I'm in Salt Lake next week, and there's some. I don't want to call them prudes, but there's some people that are kind of surprised when I drop them, and then when I, you know, make them understand I wasn't going where they thought they were, that jiggles my jello. So it's
Nice.
pretty good. But you got
Yeah.
to keep it entertaining too. I mean,
Yeah,
I make
absolutely.
no bones about it. A lot of the stuff that I talk about is not sexy. It is it's very dry, especially in Salt Lake, because you're at altitude, and they're negative grains.
But I'm bummed.
Yeah.
Um,
Not enough corn. No corn sweat.
That's it.
But no, you keep it entertaining. That's one of the things I appreciate. Going through the design class initially online, I gotta tell you that it's like I needed the toothpicks to keep my eyes open. If I tried to digest more than maybe 45 minutes or an hour at a time, it's like I can't. You can't. You know what I mean? Like, and so you have to make it entertaining for people to get it.
And your explanation of that is spot on because, correct me if I'm wrong, but Jack Rise was your instructor that you took it online, and he is an excellent. And I guess I got to say was. It's kind of sad to say. He's no longer with us, but I have a series that I do called Rise to the Top. It's called Design Essentials now, but it was Rise to the Top, and that was a play on his last name, Jack Rise. And I do a little ode to him when I start off every one of those classes. He was very influential to me when I started off in the industry. I want to say it was 1986 was the first RSCS class I ever took, and he was my instructor. So
Yeah.
through the years, I always used to kind of crack wise about it and say, someday I'm going to take your job, and
You
I
did.
did. And it was I don't want to get all mushy, but it was kind of touching because he had he was in a bad way, and he found out that I was going to be filling in for a class that he was supposed to do, and Bobby, his wife, said that he was just elated when he found out that it was me that was going to be doing the class. And he worked for me for a period of time, so I had a long relationship with the guy. He was not your normal cup of tea. He was an acquired taste. He's also a Jersey guy like me, and there are people who do not like the cut of our jib, and I'm a much, much more tame version of him. One of Jack's things was he would say, I treat men like men, women like women, and children like children." And he was certainly not a PC person, but that was one of the reasons you loved him.
Well,
It was great.
I think what I struggled with is he has his voice sounds like a it's almost like you're listening to a story, like a book on
Hmm.
tape or something. It's a very soothing voice.
Okay.
And when you're listening to a soothing voice and it's just like very polished and whatever else, and it's 8 o'clock at night after you worked a 10 or 12-hour day, and he's talking about, um, you know, CLTDs and this and that, and you're like, oh my gosh, you know what I mean? Like it's difficult to digest.
Oh, it's a very dry topic, and you have to be very interested, and you have to understand the importance from it. And again, this is another Jackism. The first thing we can completely screw up when we install an air conditioner is one that's not the proper size. And he came from a background where it was real life stuff. He wasn't doing this because he read it out of a book. He lived it and did it, and it was the way things were. So uh, I was very fortunate to spend as much time with him as I did as I moved my way through the years that I've been doing this stuff. And I it is weird because I guess everybody that's getting old says they don't feel old. I turned 60 this year, and I think I still act like a teenager at times, but I don't feel, I mean, I do feel old. I think we had an earlier discussion about I do the WWE body slam to get in bed now because I can't let my knee bend so my heel touches my butt because my knee's on fire for the next 15 minutes. But yeah, I feel that kind of stuff. But in my head, I don't feel that way. So I guess that's why I'm still doing this stuff.
Yeah, time goes by fast. I gotta say that. Like I'm feeling it too. I feel like it was just I started off the presentation at Summit with a picture of me when I was, I don't
Yeah.
know, I was like early '80s, 1983 or something like that, and
So that when you're the little kid in that one, it's 83
something like
because
that.
that's the
Yeah.
year I graduated high school.
Oh, really? So now I'm making you feel old again.
Oh, yes, you are.
But yeah, no, it like I remember the guy I put on the screen who actually was teaching me, and I remember back in the day when I was a kid, and he was like showing me different things, and now, I've been in the trade for over 20 years, and now I'm teaching classes. I'm doing a presentation for Air Distribution Institute later on this month, which is pretty cool. And
Oh, you're doing something for ADI?
yeah,
Oh, that's very cool.
yeah, I'm looking forward to it. But the point was, I'm thinking back to the times where he taught me that type, and we went over all this, and he showed me the duculator and that, and he died last week. He's 91 years old, and I'm
Oh,
thinking
wow.
back. I'm like, it just feels like it was yesterday. I was learning all this stuff.
Hmm.
Now I'm starting to get old. You know what I mean?
Yeah.
Like I'm in my 40s. So yeah, I don't know. Whatever. Time goes by.
Yeah, it's going by, and it's going by quick. Not that quick, but it is that quick. How long have you been speaking in front of people now? Is it 2 years yet?
No, just over. I
But
mean, it's almost 2 years on my first presentation, but then there was a big gap in between the first time I did it and then the second time I did it.
well,
So
the first time I saw you speak in front of people,
don't.
I'm not going to give you all the deets.
Actually,
Somebody can get a hold of me if you really want. I got it on video.
I brought it up. I brought it up for an earlier podcast, and I was,
Was
because
that the first time you spoke in front of
yeah,
people?
absolutely. I was
Oh,
terrified.
oh yeah.
That
It was awesome. It was awesome, man. It's a legendary story. But I got to say, I've seen you speak within the last year. Well, last time I think I saw you speak was at the symposium.
Mhm.
And it's funny because you can tell a lot about a person as far as at least the things that matter to me. I can remember being done speaking in front of people, and all I want to do is critique myself, and there's things I want to change and all that kind of stuff. And the only way you're going to change it is by doing it. And
Mhm.
I've just been very fortunate. I've had a gig where a typical year I'm speaking in front of 5 or 55, maybe 50, 60 times a year. And a lot of those classes I did were on the same topics. And I'm pretty much in that grind right now. A lot of the stuff that I'm talking about now, I've been talking about for almost 20 years or more. So it's very simple. Uh, my poppy, my grandfather used to call me Chainsaw because from the time I was old enough to speak, I never shut up.
Hmm.
I have the gift of gab, and without sounding arrogant, I was good at what I did. I might not have been the best employee, but I was good at that whole system performance. And if something was wrong, I could fix it and that kind of a thing. So when I got the opportunity to do a class because the instructor didn't show up, that's what started my whole path to lead to where I am now. And it's work, but it's not work. I mean, I have crawled in an attic recently because I got squirrels in my freaking attic, and that's a whole thing. My wife's been taking care of it while I've been out here this week. But the actual working part, it's tiring. The travel sometimes isn't glamorous. Although I'm flying first class on the way home, and because
Nice.
I it wasn't that much money to do it, so I'll pay out of my own pocket to bump up because I have a short layover and I don't miss a meal, and I was afraid I was going to miss my meal, so I already ordered my um, braised short rib for the flight home.
Nice. That's awesome.
But there's times where it's not glamorous, but there's times it's almost incredibly glamorous. You're starting to get a peek of it now
Yeah.
when you walk around and people you don't know come up and they talk to you like they know you, and
Yeah.
it's kind of weird. But I'm not going to say I dislike it because I don't dislike it.
Yeah.
Uh, but I can be the same person when I meet somebody that I've seen on TV or something along those lines, and it's even weirder when they come up and they know you.
Hmm.
So that's something to, I guess, you can look forward to. But I do want to say that I watched you do your class today. You've come a long way in a very short period of time,
Thank
and
you.
it's going to get easier. And I don't know. Uh, it's been a lot of years since I actually have rehearsed anything.
Mhm.
Uh, I I think it sounds more genuine when you get up in front of people if you just speak like you're having a conversation. I don't ever want to sound rehearsed,
Mhm.
but I don't know that I've ever done anything that I could say where I rehearsed to do it. There's Dan Holohan. I don't know if you're familiar with Dan
How
Holohan,
to teach text without.
putting them to sleep.
Yep.
And his thing, there was one sentence in the book or one paragraph where he spoke about he had somebody come up after a class that he did, and they made the comment, "You must have been speaking on this topic for a long time." And he said, "No, I just made sure I was prepared." And a lot of his paragraphs would end with "pal." So make sure you're prepared, pal. And I was fortunate enough once, the place I used to work, uh, myself and two of the gals that I worked with, we worked a booth at a distributors trade show, and Dan and his daughter were in the booth next to us, and we would have 20 minutes of foot traffic, and then we'd have 45 minutes while the sessions were going on where we would just sit and talk. So I had seen him once before, and I got the opportunity for, I think, 3 different 45-minute sessions to sit and talk to him and his daughter. So I don't know him, but I can say I've had some conversations, and uh, I've read a couple of his books, and it's good information. So it's kind of cool to read somebody's book who started teaching way before me, but in the same, I'm going to call it the same era, because I started teaching before laptops were a thing. Uh, I had an overhead projector, but I can't spell and I have bad penmanship, so I dropped that overhead projector pretty quick, so it didn't work. So I didn't have to use transparencies that nobody could read anyway. So, but he used to talk about being prepared, and I would show up to every gig that I did with the intention of using a real chalkboard or a dry erase board, or I had an easel and I had one of them giant flip charts, and I could write on that enough. And I would use a workbook that I'd start every class with a 10 or a 12 question quiz. And for the first 15, 20 minutes of class, they would fill it out. And the first question was, what's your saturation temperature for R22 at 40 degrees? And you knew really quick who understood how to read the saturation chart. And that just turned into measuring superheat or measuring subcooling and all that kind of stuff. So it's, again, if you understand how an air conditioner works, it's very straightforward. If you don't, it's a really good introduction to how the stuff works.
Yeah, I gotta say, a lot of this is, I didn't even realize. It's like, I know John Ellis says it a lot. You don't know what you don't know.
Very true.
And the more I went out to try to seek the information, the more I'm like, man, I suck. This is,
It can be very humbling, but at the exact same time, I am a big advocate of stay in your lane. And I have been surrounded by people over the years who are very good at that. And there are some people out there that are not. And I have zero problems making fun of those people. You don't get up and pretend that you know stuff in front of people, because eventually somebody is going to point it out. And uh, you have a beep on this, because I'm a sometimes. And when I first started teaching, I was way more arrogant than I am now. And I remember being it was a scuttle humidifier class, and the instructor was talking about how the hot air in a furnace, the temperature rise, is what made houses dry. And I'm like, well, that's not it. Because if the temperature rise is what sucked the humidity out, there's got to be a white pipe somewhere where it's dripping out.
mm-hmm.
So 3 different ways I asked him, where's the water go? And he gave me these political answers, which I think everybody's familiar with. The person uses a lot of words but doesn't say anything.
Mm-hmm.
And then I let it go after, way too much time. And then at lunch, we were up there getting our coleslaw, and he's like, what was the point you were getting at? And I'm like, you don't know where that water goes, do you? He didn't understand that, the furnace could be at fault and it's creating excessive infiltration, and that's what's driving the moisture out of the structure, but it's not getting lost in the temperature rise. That's where we start to get into the difference between relative humidity and absolute humidity. And he had no idea what I was talking about. I learned a lot about myself from that one, because I was driving home that night, and I'm like, I'm either never going to talk about stuff that I'm not in full command of, or I should stop, because karma's going to bite me in the ass. And I generally do not. I'll go up to somebody after a class and say, what's up with that? But I try not to be that guy anymore. But I do know people that don't stay in their lane. And I'll talk about them behind their backs. So that's kind of fun.
I hope it's not me.
It's certainly not you.
Okay, good.
But it does.
I think I actually made a comment today in the session that I did, that I'm like, yeah, this is not a manual D class, and I'm going to stay in my lane. If you want to learn about that, go talk to Ed.
It's a good way to do it. And the funny thing about this stuff, and I've spent a lot of years, again, at my previous job and at my current job, where people ask me questions about what's in those books. I've learned more about what's in those books by people asking me questions than me reading the book. because somebody will ask. I had one. Well, I had like 4 of them that I dealt with yesterday, where I have people that will ask me questions, and I have this whole order. If they're members, I'm supposed to get back to them in as short a period of time as I can. But if they're rando questions, and I heard you do it today. I have a soft spot for anybody that took their time to come listen to me speak. So I'll always make time for them. I'm not going to stop in the middle of an interview to answer their question, but as soon as I have time to actually research it, if that's part of it. Somebody asked me the specific question because Manual J says that you're supposed to measure from outside wall to outside wall when you do the dimensions of something. And I had done a quick Hey Ed video that said that. And he's like, where is it specifically in the book? And as I'm reading through his, or like behind his words, I have seen where people are filing for rebates. Like they're doing a Energy Star thing. And the builder is saying the house is 2,000 square feet. And the person who did the load calc is saying it's 1,850 square feet. And the discrepancy makes it so that the incentive gets paid on the smaller amount. So if you measure the inside dimensions versus the outside dimensions and they're 2x6 walls, you can have that much of a discrepancy. But the heat loss takes place from the outside to outside, not from the inside to inside.
So that's interesting that they'll pay a rebate based on the square footage in a Manual J report.
It's not just a Manual J report. Anything that quantifies the area of the structure, they're going to pay the lowest number that comes out.
Wow. Okay.
And I don't fault them. So it's especially if it's taxpayer funded that's doing it. I want to pay the least amount as possible, and it kind of goes in line with I want the person doing the most accurate load they possibly can, and the most accurate load is going to come from the outside dimension. So I've learned a lot of what these books say. I had one recently where internally we were not arguing, we were having a good discussion, and somebody brought up the difference. Manual D talks about you can use for a standard induction motor or PSC with a constant torque ECM, you can size the blower or use it to populate the friction rate worksheet all the way to the top of the blower chart. But with a constant airflow motor, what's commonly called variable speed, I believe the number is 70% of whatever is on the blower chart. And I had no idea that it said that. And I had somebody asking, well, is this what it means? They were quoting what the book says. No, it has nothing to do with that. It has nothing to do with that. I wouldn't even let them finish what they're saying. Like, no, it has nothing to do with that. And it had everything to do with that. I never knew that's what the book said. So I still get surprised at time of what's in the books because you really got to pay attention. But then you accept the fact that, well, I would always tell people if they were putting in a variable speed or constant airflow motor, the lower your external static pressure, the less watts that you're going to use, and the more efficient it's going to be. Again, the design series isn't about efficiency. It's about providing a piece of equipment that meets the requirements. And while we are energy agnostic, we don't want to excessively use energy that's not necessary. So what I was recommending to people in the design would work out best for them, and it would meet the intent of what it says. But I'm wrong. So I have no problem saying it. And plus I'm married, so I hear it a lot. So it's not that uncommon.
Yeah. I got to say, though, that that was something that I struggled with for a while is understanding the friction rate worksheet. And you know what made it click for me was I found one of your earliest videos that you made on YouTube. And it was like you sitting in your basement. And you're like, all right, I'm watching TV. And somebody asked me, how do you fill out the friction rate worksheet and what it is? So, and you just took like 5 minutes.
Yep.
And you're just like, bing, and you just explain everything. You're like, okay, I'm gonna go back and watch TV, and that was it.
Yeah.
And I'm like, wow.
I'm going to say that might have been a college football Saturday, and that's what sparks me to do some of those. Actually, I have a bunch of videos that are 4 years old, and I hadn't done one in 4 years, but within the last, I don't know, month and a half, I made a couple of fresh ones. But that's what it is. I'll go online, and I'll still argue with people online.
Yeah.
And I don't argue unless I'm right, because everything that I'm going to argue is math based. So that's kind of fun. I had somebody recently that went on this tirade, and he couldn't even get the ASHRAE acronym right. And he was saying some stuff. And I'm like, I don't even really want to talk to you because everything you're saying is wrong. You're trying to quote the stuff out of the SEER rating, and you're saying the return temperature is 75. It's not. And went through all this. And I was amazed. I'm used to people, after I present facts to them, they just delete everything.
Yeah.
But he didn't. He actually said I was correct, which was pretty impressive. And I was kind of demeaning. I was saying, you were an instructor. I'm surprised that your techs were able to distinguish the difference between putting the blue hose on the big pipe and the red hose on the little pipe. Maybe I was a little carried away, but from some of this stuff where he was being sarcastic to me, he was telling me to go find my mentor and get them to explain it to me.
Well,
So
I've seen that a couple times where people like start laying into you like, what do you know about duct design? And I think I've actually commented to be like, hey, do me a favor and just Google him.
Yeah.
But yeah, that's always a funny thing when, and the problem is, I think with tone, you don't really understand somebody's intent online. And that, I did ask you a question, this was years ago. And I remember, cause that was one of the things I didn't really understand. And I remember you saying in one of your videos that, equivalent lengths are based on, 700 feet per minute velocity return, 900 feet per minute velocity on the supply. And I remember I asked you, and I don't remember how, maybe it was in a YouTube comment or something, but I was like, hey, so what if we have lower velocities? Like, what happens to the ELs? And then you like came on, and it was like one night, and you're like, hey, yeah, I was watching TV, and you scratched out on a piece of paper. You're like, here's the math on how to correct for the EL.
Mm-hmm.
And, you showed it. And I remember, and I thought, I'm like, man, that was awesome. And it was really quick. You answered my question immediately. And then I went down the whole rabbit hole of trying to take a system, which was a ducted mini split. And I'm like, all right, I'm going to correct for these ELs. And it's like an iterative process that is a waste of time. Because it's like you swing back and forth over and over again. And
I used to show people the math, and it's math with letters, and I felt pretty good about myself. I figured out how to use it. And then one day I turned the page. There's a chart. You don't ever have to do the math.
Oh, really?
There's a chart that goes all the way from an EL that maxes out, I think, around like 150 feet, and it takes it all the way down to 5 feet. It's just what happens, and it has something to do with math with letters. It's not, if you take, and I'll use 900 feet per minute. If you cut that in half down to 450 feet per minute, it doesn't cut the EL in half. I think it cuts it cubed.
Mm-hmm.
I need Steve Rogers over here because I don't understand that math. He's the one who showed me how to do a whole bunch of that math. But it makes it so that the ELs are significantly less, and it goes right back to what you were talking about. It was a ducted mini. It was a low static. If you follow the guidance in Manual D and you don't adjust your ELs, you're never going to have any available static pressure. Mm-hmm. And if you fix it, as far as adjusting those ELs, all of a sudden you have enough oomph. And the reality is, if you follow Manual D, specifically how it's written, and you end up with any fittings or any ducts that aren't at that 700 or 900 feet per minute number, your external static pressure on paper versus what you measure in the field, it's going to be less. And then you sometimes have to adjust your blower speed to achieve that airflow, or your airflow is going to be too high. And yes, I said your airflow is going to be too high. So if you're doing metal ducts and you're doing at least a decent job, you almost always come out with external static pressure that is lower than you originally designed. If you're using flex, that might not happen because people traditionally don't use flex the way it was intended to. But if you start comparing a properly filled out friction worksheet to what you measure in the field, you'll start to understand what you're doing right and what you're doing wrong. And it all goes back to that M word. You got to measure stuff.
Yep.
So once you start measuring stuff, I don't know, and this goes back to Steve. I don't know if he was the first one to say this, or I got it from him, or he got it from me. But I want to know the truth. And when it comes to HVAC, Math is the truth. There's no opinions. It goes back to when I'm going to bicker with somebody online. I'm not going to talk about something I'm not well versed in, and if it's not math based, I'm not interested in arguing, because who wants to argue when you can be wrong?
Yeah.
Right. That's why my wife's always right. So
Yeah.
it's just how it works
And
out.
those conversations usually start with how long somebody's been doing something.
Oh yeah.
For.
Yeah. So you've been doing it for 30 years. Well, I've been doing it longer, but I've been doing it right longer, because you've been doing it wrong for a long time. And I'll be happy to explain it to you. But I purposely am kind of a dick when I say things. Maybe it can be taken that I'm being that way, and maybe you're just misconstruing how you're reading me. But there's a chance, yeah, I'm being kind of derogatory, because there's times I don't have time for it. But I also go in spurts. I'll go for 3 or 4 days in a row where I'll look at stuff, and then I'll go for 2 weeks where I don't look at stuff. And sometimes I'm better off not looking at stuff, and
Yeah.
maybe there's times I should pay attention.
I think
a little bit
more. You're justified to I don't want to say be cocky with people or whatever online, but yeah, kind of. You have a lot of experience. You have a lot of knowledge, and I'd be upset too a little bit if you have a pretty notable position in the industry and you're pretty well known, and then you have somebody that comes across online like, well, what do you know about airflow?
Yeah,
It's like,
I know a little bit. And I'm not afraid to point out when I didn't know something. Again, I'm going to bring Steve up on this. I remember there was and this is probably 4 or 5 years ago, there was a conversation, and I made the statement, well, it's easier to bring air back to the fan than it is to push it away. And Steve's like, no, there's a pressure difference, and it doesn't matter if it's the supply or the return. And I'm like, but the ELs in manual D are shorter for the same size fitting and the same height to width ratio on the return than supply. And I don't recall if he directly pointed it or it made me go in a huff. I'm going to go look in the book and find out. And it's simply for the fact the return fittings are done at 700 feet per minute, and the supply, it's 900. And I'm like, shit, I got to stop saying that. So, again, I'm not afraid to admit that I'm wrong. Sometimes I might do it begrudgingly, but it's math. So you can't sit there and defend yourself and say it's right when it's not.
Yeah.
And I would rather understand it properly. But I do get a kick out of the watching a football game. It's halftime, and I got some numbnuts that's trying to say something, and I'm like, what you're saying is wrong.
Yeah.
A big one is you can't have a nominally sized evaporator coil. You can't have a 2-ton evaporator with a 2.5 or a 3-ton outdoor unit.
Yeah.
And I don't know. I can find AHRI matchups that are like that. I can find expanded performance data where they'll say if you have a smaller evaporator coil, you're going to get better or worse dehumidification depending on who you're talking to. And I can prove it both ways. But you're making the statement. You're not showing the return air conditions. You're not showing how many CFM are moving across it. You're making these blanket statements, and that's not how it works. I'm well-versed in reading expanded performance data. And if you want to spend 15 minutes listening to what I'm saying, you can be just as good as I am at it, because there's nothing hard about lining up a couple of numbers and a couple of, well, they're almost are. Yeah, they're all numbers.
Yeah,
they're outdoor temperatures, they're indoor temperatures, and
model number.
Humidity, the model numbers, and some fluid movement. That's a fancy way of saying airflow.
Yeah.
So none of it's hard, but it's one of those things that once you become accustomed to it, it's just part of it. It goes. I have a rant about. There's a lot of people out there that are good at selling air conditioning. And there's way more people out there that can do that. They can tell you how an air conditioner actually works. And I'm not talking about how much Freon you put in it and that kind of a thing. I think everybody who is selling air conditioners should be able to explain what sensible heat ratio, or if you want to be more precise and call it sensible heat factor, is, and how that ratio affects the system's performance, whether you're going to get better latent or more sensible, higher efficiency or lower efficiency based off all these things. And every time I start to talk to people like you who get it, I'll say 10% of the industry understands it. And I got somebody's like 3% maybe. And it goes back to that whole thing with Brian Feeney when he said, we got to get these people just to use the tools. Maybe later they'll figure it out. But if they use the fancy tools, they'll get the answers, and that will point them in the right direction. And if if I get hung up on the fact that they have to understand it completely, they might never get there. So I do have to change the way I think a little bit.
I think we all do.
Yeah, it's not a bad thing.
Times are changing. There's a lot that we got to get used to. There's AI. There's
there's a whole another rabbit hole.
Yeah.
I use it. I use that whisper thing. I do a lot of voice to text, but I actually recently wrote an article about AI, and I asked ChatGPT directly, "Can I trust you?" And it came back and said, "Well, if it's grammar, if it's punctuation, yes, but if it's technical, no. If it's legal, no. If it's medical, no." And I was like, "Well, all right. Are these answers legit, or is it just trying to appease me?" And I finished the article with something along the lines of, maybe we can start to use it, but we have to trust but verify, or maybe the cyborgs will come down and kill us all before you finish reading this. And that's the way I literally finished the article. So there's benefits to it, but my analogy with it, I did it coming here. I'm in the dentist office, and I'm checking in for my flight. And I realized, because this service that we use at work, sometimes I fly a different carrier in each direction. And when I opened my United app, my flight to come out here was not there. And my United confirmation number wouldn't work in my Southwest app, so I could check in. And my dentist is 5 minutes from my house, so I had before I went in and got my caps put on and going home and all that, so I panicked for, I don't know, 30 minutes. And I spent another 20 minutes on the phone trying to talk to somebody, all while AI is saying, put your phone number in, do this, do that. And it's all it's doing is adding another level of frustration, because very rarely do these phone prompts allow me to do what I want.
Yeah.
I would have went to united.com and fixed it if that was a path that would have worked. So I compare the AI to a lot of those services, and I understand they're trying to reduce the human interaction, because it costs a lot less to let the AI do it, but it doesn't produce better customer service. So it has its place, but not every place. That was a good way to wrap up that thought.
Yeah. Well, on that note, originally we were talking about going for a half hour. We're like an hour and 15 minutes in. You're easy to talk to, though. I think that's usually how most of our conversations go.
Oh, yeah. Well, I've never spoken to you on the phone for less than an hour and 15.
Yeah, absolutely.
Yeah, it's kind of funny. And that whole diarrhea of the mouth that I get, or chainsaw, as my grandfather called me, is
But you always have
pretty
interesting
accurate
things to say, and that's like we were just talking about the human interaction thing, and now we're here in person. So yeah, awesome.
No, it's good stuff. It's been a great week.
Yeah.
I enjoy the conference. This is 2 years in a row that I've come to this one. I was invited last time, and I just hung out, and I got to speak at in a couple of different ways at this one. And as long as I'm invited, I'll come back every year that I'm invited. So
yeah, hopefully we still have some. We continue the not, I don't want to say partnership, but like the camaraderie or whatever between ACCA and NCI.
I agree. There's some stuff coming up where I'm trying to get you guys to work in concert with us, because without question, there's things that you can do to help us, and there's things that we can do to help you guys, and there's no reason not to continue that.
Awesome. And ultimately, both of us together could help a lot of HVAC people.
I agree.
Yeah. Awesome. Well, thank you. We got to go get dressed up, because now it's the fancy awards banquet thing. So
brought a jacket with me.
Awesome. Well, thank you, Ed, and we will talk soon.
Cool. Thanks, Adam.